Okay, so for today's discussion, we will discuss about analysis and design for axial compression. On the previous discussion, we discussed about tension members. So the other way around could be the compression members. So what are your compression members? So basically, those members that are experiencing compressive force is your compression members. But the most common to us as a compression members is our column. So yung pinaka-common sa atin na compression member are the columns. But not most of the times, columns lang, hindi naman lagi na columns lang yung ating compression members. We also have compression members in the trusses and in the bracing frames. For the columns, we usually use W shapes or wide flange as our columns with a nominal depth of 350 millimeters or less. Okay, this is the difference, the obvious difference between beams and columns. Sa beams, may mas particular tayo on having deeper depths rather than wider flange. Sa columns, mas gusto natin na wide yung flange kahit na yung ating depth is medyo maliit. Okay? So, because what we are more particular with your columns is that the area of our section. Kasi yung ating force is applied to the area or the cross-sectional area of our section. Unlike kasi sa beam, di ba yung beam natin pag ganito, yung top view niya, dito natin ina-apply yung area sa buong flange. So, malaking area that receives our force. So, yung ang kailangan natin to resist flexural stress and also shear stress, yun ang kailangan natin i-resist sa columns. Kaya we need deeper beams. Unlike sa column, it tend to be compressed. So, we need wider areas or wider plunge. Okay. It could also be a built-up section if needed for large structures or heavy. So these are for your trusses, we can use single truss or we can use yeah, we can use double truss with equal legs or unequal legs, what may be economical. Okay? And for us to know what is the most economical section is the least radius of gyration. Una yon, least radius gyration, and the next one is the lightest among our candidates for the selection of your members. Okay, so top chord natin, it can either be bolted for the trusses no, or welded. Lagi ko naman sinasabi, connections are either bolted or welded. We already discussed that. And yung inyong pair of angles, it can be welded together or can use gusset plates para ma-weld natin siya together. Yung gusset plates, ito yung nakikita nyo na parang kala nyo piraso lang ng ganyan, yung mga ganyang shape, tapos may truss. Diba? May truss na ganyan. Akala nyo piraso lang siya ng bakal, pero pwedeng welded siya doon or bolted siya sa gusset plate. Okay. We can also use structural tees if we don't want to make double angles. Pwede tayong gumamit ng structural tees, no? Kung ayaw natin gumawa ng double angles. Pwede ng structural tees. Okay. So, for this topic, these are just definition that our vertical compression member can be called as columns, most commonly, or post, or stanchions. Compression for trusses is called struts, and for cranes, these are called boom. Okay, so columns can be short. Yung short columns natin subjected to crushing and to behave like members under pure compression. Pag naman longer yung column natin, it tend to buckle. But don't be so decided na pag sinabing long column, ibig sabihin it has a long span. It could be, it could contribute, but on the later on this topic, you will discover what really are the components for us to consider that your columns is a short column or a long column. Okay, so the first theory, we have two theories that we are going to apply in the study of columns, understanding columns. The first one is the most common, the Euler column backling theory proposed by Leonhard Euler. Okay, so yung analysis niya is regarding the elastic curve, no? And meron siyang comparison with the factor of safety and the slenderness ratio. So meron lang siyang dalawang consideration if the column is pinned or fixed-ended. So madali lang tandaan yung formula. Actually, you just have to memorize. If you want to memorize, you only have to memorize this critical force, no? Later you would know why. Okay, so for the critical force for a pin-ended column, we use pi squared multiplied to your modulus of elasticity multiplied to your moment of inertia divided by the square of your length. Yan. Okay, take note that your length is unbraced length. When we say unbraced length, for example, this is our bracing, this is your beam, and this is your column. So this section between your bracings is not included. Instead, we count it as a beam. Kasi ang ginagawa natin sometimes in our connection, hindi naman straight. 'Di ba? Kasi hindi naman tayo straight nagbi-beam, nagko-column sa steel. Unlike sa concrete kasi pwede natin siyang buhusan. So, it could be more prone to backlink pag gano'n. Kakat natin siya here. So, yung mas ginagawa natin buo yung ating beam. Okay, span ng beam natin. So, yan. Yan. So, that's what we are doing. Unbrace tayo. So, from here to this and here, that is your unbraced length. Okay, so if we have force, critical load, we also have a critical stress. And stress, as we all know, that is the force over the area. Okay, if your force is expressed as your pi squared E I over L squared divided by A. If it is expressed as this one, we can actually, this one, okay, we can actually manipulate the equation, no? Pwede nating i-manipulate yung equation. If your, pwede natin, for example, di ba, bawa, pi squared E over L squared. Pagka ganito yung equation natin, is this, or, no. This one. Pi squared L over I. Yung L squared over I tayo, no? Over A. Yan. Yan. Okay, I will rewrite it. Okay. Over L squared over I. I-multiply na natin siya sa 1 over A. Okay, so as you can see, it could be the same as this one. Pareho lang to, no? Kasi pag ito dinivide mo into the, yung ito dinivide mo into to this, you would take the reciprocal of this one. So, yan. And by having that, we can also, yan, and we divide both all of this formula. Let me rewrite it again. Okay, it could be divided by I over A. Okay, let's see. Okay, that's it. Yes. Okay. So, if that's so, we are going to have that one. You can see, no, makikita nyo na yung ating, this is your moment of inertia divided by your area is actually equal to the square of your radius of gyration. That radius gyration can be found on your economic section. And or the formula, the real formula for the radius of gyration, is the square root of your I over A. Okay, so we can say that it this could be expressed as your r squared. Okay. Therefore, if that is expressed by r squared, we can have your pi, that is pi squared e l squared over r squared. Okay. So we could express this as this one. Okay. Now, so the slenderness ratio, ano naman tong significance itong L over R? That is actually your slenderness ratio, or the ratio of your length to your radius of gyration. The ratio on how slender your length is compared to your radius of gyration. Okay. So, yun yung formula natin for a hinge-ended column. Pagka pinned or fixed-ended support, hinge or pin. Pagka fixed-ended support, yung critical force natin is minimultiply lang natin into 4. Yan. And of course, yung stress din natin would also be multiplied into 4. Okay. How about this column theory? Okay, we also have another theory for columns. First, let us understand your effective length. Yung columns natin, we don't really have pin-connected columns because as we all know, pag pin yan, yung movement niyan could move like this, diba? Ang gusto natin, stable yung ating column. And kung pin-ended yan, yung maapektuhan yung stability. And so that for us to counter that instability, we are having the effective length factor K. And it is used to modify your unbraced length. Okay. And your KL is your effective length. And this length, ng length na to is approximate the length over the column will actually buckles. So yun yung length on which we assume your buckling will happen. It is your effective length. So yung effect ng effective length factor sa ating actual length, it can make it shorter or can make it longer yung ating unbraced length. Okay. For the slenderness ratio, okay, this is how we explain this figure. We can say that the more slender or habang tumataas yung ating slenderness ratio, mas nagiging critical yung ating stress. Okay, this is our end fixicity factor or your effective length factor. Okay, so you can see if both ends are fixed, these are the values. If both ends are hinged, these are the values. If one end is hinged and the other is fixed, so this is also the notation. Okay, so we have two values given, the theoretical one and the recommended one. So what if you are not given with the proper value? So I recommend to use the recommended one because this is the recommended one. But of course, problem may be tricky. You can start to memorize the values. Anyway, di naman masyadong mahirap i-memorize. So theoretical and recommended values. But for the actual practice, use the recommended one. Okay. So now, in selecting our most economic section, so the first thing we have to do in designing is to select, of course, our section. So for us to select our section, we need to identify our stress, actual stress, or the allowable stress. Then, to solve for your P and to solve for the area. So yung area, dyan natin makukuha yung inyong required area of your section. Okay, so we have to categorize whether your column is a short column or a long column, okay, in order for us to solve this one. Okay, for us to categorize or characterize whether your column is short or long, we have this so-called compression index, CC, that is solved as square root of your 2 pi squared E over Fy. Okay, this is not intermediate. This is supposed to be short columns. If your slenderness ratio of K multiplied to L over R is smaller or less than your compression index, your column is said to be short column. And for a short column, we have this formula of mm, 1 minus K, or the slenderness ratio squared, over 2 CC squared multiplied to your Fy and the factor of safety. This factor of safety is equivalent to 5 over 3 plus 3 over 8 multiplied to the ratio of the slenderness ratio to the compression com, compression index minus your 1/8 of the cube of the ratio of your slenderness ratio and the um, compression index. So, madali lang naman siyang tandaan. Isang 5 over 3, 3/8 and 1/8 tapos cube. Okay. Okay. Pag naman your slenderness ratio is greater than or equal to your compression index, the column is said to be long. Okay. Then your, ayan. Pag equal, so meron tayong dalawang cases, no? If it is equal or it is greater. Okay. Those are both long columns. Okay. So, since equal pala yung CC natin at yung ating KL over R, no, i-assume natin yan. We assume that your FA, since equal to, so this would be cancelled, no? So, we can have your FA is 1/2 of your FY over your FS. So, what is your FS? You will use the same formula para hindi kayo nagme-memorize ng maraming formula. So, since this is equal, this would be equal to 1. This is also equal to 1. So, FS nyo is 23 over 12. As easy as that. And then, from that formula, we can transform, no, the equivalent of your square root of your CC in terms of Fy. So this would be your Fy. And yeah, papalit nyo lang naman dito sa equation yung equivalent ng CC. So that you can have the formula for the critical stress for the theory of columns as 12 pi squared E over 23 multiplied to KL over R squared. So definitely, these are just derivation. Actually, on the book, ang makikita nyo lang formula is this one. Sorry. Ang makikita nyo lang formula is this one. Yan. Yan lang yung mga makikita nyo formula. But I'll just include and indicate the derivation so that you can have options. Pag nakalimutan nyo yung formula, at least you can derive the formula used. Okay. So refer to the next video for the sample problems.